All right, so I had asked you to go through and get this done by hand. Now we're doing it by calculator. So again, what you want to do this, your first step is to go to Stat, Edit. If you have something in your list, arrow up. Do not hit delete. Hit clear. Watch what happens if I hit delete. If I go to the next one, I arrow up and I hit delete. What just happened? The list is gone. Oh no! I deleted another list. What if you delete everything? If you've accidentally deleted instead of cleared a list, the way to get it back, and again, I'm not helping you with this on a test or quiz, so pay attention. To get that back, you are going to go to Stat, and then right there at the bottom, you see where it says Setup Editor? Hit 5 and then Enter. What that's going to do is that's going to redo your lists so that they're all back. And what's really kind of cool is if you accidentally deleted a list instead of, just trying to delete one of their entries, it's actually going to pull back anything that you had in that as data right when you hit delete. Okay? So again, when you want to clear out stuff that you don't want, arrow up and hit clear. Enter. Do not hit delete. But if you do hit delete, Stat, Setup Editor, Enter will take care of it. The clear list is just a really long way to clear, just like I said, going up and hitting clear rather than delete. It's just a long way of doing it. Okay? All right, everybody good with that? So what I want you guys to do is I want you to go to your calculators. In Stat, Edit, I want you to put all of this data. Put that into your calculator for me. You should have this table in front of you, so I shouldn't be blocking any of your numbers. And I want you to kind of see something that's very helpful here. Do you see how it actually tells me? Here are the word lengths for the first 25 words. That means I should have 25 pieces in my list already, and that means my blank should be on 26. So if I were to go up, you see how that says the 25th one? Now, just for giggles, let's say I realize I accidentally didn't put in the 8 that I needed. And you're worried about the order, because sometimes it does change things. Not here, but sometimes it will. You can go to where the 8 should have been after the 5, so I go after the 5, and I hit second, insert. And it puts in a spot for me where I can fix that. Okay? It's really kind of nice that you can do that. I mean, delete is obvious. You'll remove that whole entry. But insert also works very nicely for that. All right, so does everybody have their data set up for me in your table? Ah, there it goes. All right, now we're going to do a histogram. You've been asked to do the dot plot. Dot plots are easy to do by hand. You literally just put your numbers and you put dots. But how do the histograms work on the calculators? Here's what you need to do. Now, let me preface this. If you are taking any other math class with this, you need to understand how to undo this. Because sometimes you'll go, oh, now I want to graph a line. I want to graph a parabola. I want to graph this ridiculous calculus thing. And you'll get an error message. And if you get an error message, you're going to come and kind of undo what I'm going to do right now. So you're going to do second, y equals. That takes you to your stat plot menu. Now, depending upon if you're using one of your calculators or one of mine, your stat plots might already be turned on. But we're going to just work with one graph at a time right now. So you're going to go into that first one and make sure that it's on. Okay. Now, we have all of these different options for what type of a graph. This first graph, we're not going to do that for a long while. That's actually your just straight up scatter plot. So plotting a whole bunch of XY points. This one does the same thing, but it's then going to connect those dots. Again, we're not going to use it for a while. Guess what that one is? It is a histogram, not a bar graph. Okay? You cannot do bar graphs on this. Okay? This next one and this one that comes after it are both box and whisker. But it's kind of like upper level box and whisker versus elementary box and whisker. We will be using the upper level box and whisker, and that's the box and whisker that has dots associated with it, because those are going to be your outliers. It's going to identify my outliers for me. And then this last thing, we will be using a couple of units. That's going to be for something called an NPP plot, or a cumulative graph of some sort. So it's a cumulative percentage graph or percentile. We right now, want the histogram. Now when I select histogram, I have a couple of options. My first option says list. That just is telling me, where did you put your data for this? Now, we have all sorts of lists that we can do. So, like, if I wanted to do something and I had actually put the data in list 3, look at each of these numbers, 1, 2, 3 above it, list 1, list 2, list 3 in blue. So you can change your list by doing second and then your number. That'll get you list 3. Second 3 will give me list 3. But right now I have all my data in list 1, so I'm going to do second 1 for list 1. Sometimes I might come forward and tell you, all right, we're going to be using the numbers from 10 through 20, but it just so happens that I have 100 10s and 97 11s and 38 12s. And you're not going to want to sit there and type that into your calculator. 100 10s. That would really suck, right? Be terrible. So sometimes what we'll do is we'll have a first list be nothing but the values, and then we'll put a second list in there that tells me how many do I have of each of those, a frequency list. So sometimes we will have a list here, but since I'm only dealing with list 1, my frequency is just 1. 1 for everything that I put in. Now, we've got all of our data entered in. We have our plot set up. The next step you're going to do is zoom. Quit out of that first because I forget sometimes these messages don't like it. And then zoom, and then you're going to either arrow down or hit 9 for zoom stat. Now, if you got an error message, or when you graphed zoom stat, some line or something else showed up over the top of it, but especially if you have an error message, because sometimes your calculators are in your book bag. They get accidentally turned on and buttons get accidentally pushed and you get weird stuff. So if you get an error message or you see other stuff on your graph, go to your y equals and make sure that everything is clear. Because that just does, like, I had somebody in the last block that for some reason had a whole bunch of rows of arrows. I don't know why. Yep. Calculator gets turned on, button gets pushed. So if you get an error, the first step to check is go to your y1 or your y equals and make sure that's all clear. And then again, just zoom stat. There's everything. Zoom stat does a very special thing for me. It makes sure that from the smallest value in my list to the largest value in my list, it's represented. It's going to make sure that I can see the axis and points above and points below it. And it's going to force it to make usually somewhere between 6, 7, or 8 bins. And by bins, I mean each one of these box towers. Bins are going to be, they hold those values. Do not rely on what it does when you zoom stat for a histogram. Let me show you what this means. Click your window button for me. This window button tells me my smallest bar is going to start at 2. My highest bar is going to go up to 12.5. And I'm going to count by 1.5. Look at these values. Does counting by 1.5 make sense? No. Things we typically count by. I know, hard to believe. 1. Have you ever counted by 1 before? Never. 1. Sometimes you count by 2s. 2, 4, 6, 8. You can count by 3s, you can count by 4s, but not something we typically default to. We'll count by 5s, count by 10s, sometimes 15, but not usually. 20s, 25s, those make sense. 50s, 100s, those guys make sense. Counting by 16.4 makes no sense. Okay, so we want our bin width to make sense. We also want our start and end to make sense with that. So on this, my lowest number was 2, and my highest number, what was my highest number? 11. So I want to make sure that I go from 2 all the way up to 11. Now, for your graphs, the minimum number of bins you are allowed to have is 5. Okay? There's nowhere that it puts that down as a specific rule. It's just, I know the size of your data sets, and if you have fewer than 5 bars, you're not showing what you need to be showing. Okay? You can have more than that, but you want no fewer than 5 bars, and you want your bars to go up at least to a frequency of 3. Because if you have everything at a frequency of 1 or 2, it's going to look uniform, no matter what. Okay? So I want to have at least 5 bars. I'm going from 2 to 11. What do you think I should count by? If I count by 1s and I'm going from 2 to 11, how many bins will I have? It's going to be 10. Because most people think 11 minus 2 is 9. But then you're counting that first bin as well. So you got to add 1 back onto it. So let's see what happens if I do that. If I go from 2 to 11 and I count by 1s. I'm going to hit my graph. I mean, that's okay. But I have 1, 2. I've got a couple that go up, so that would be acceptable. But they're still pretty kind of short, and there's not much variation in height. So what I can also do is if I go back to my window, what's something else I can count by that makes sense? 2. But if I count by 2, will I go from 2 to 11? No, what would I count from? I would go to 12. Because it's not how many bins you want. It's talking about what's your lowest value to what's your highest value. So now when I look at my graph, that's a little bit clearer as to what kind of data is going on here. Does that make sense? When you do your dot plot, you probably did your dot plot by 1s. And that's fine. Some of you looking around did your dot plots by 2. That's okay also. But you want to make sure that what you're counting by makes sense. And although your zoom stat will automatically force your graph to fill your screen, that doesn't necessarily mean that's the best choice. It's almost never going to be the best choice. Some other things that you can fix. If I go to window, one of the things I like to do, because I want my bars to go from the bottom of my screen to the top of my screen, I change my Y minimum always to just negative 0.1. Because what that's going to do is it's going to let me see the line, but nothing underneath it. And then I'd say, okay, let's see what that's going to look like. That's nicer. And I want the graphs to kind of fill from bottom to top. So watch, this is so cool. I absolutely love this. If I hit the trace button, look at what it tells me. It tells me that this bar contains values that start at 2, including 2, equal to, and going up to, but not including 4. So it means this bar contains 2s and 3s. And how many are there? 10. The next bar contains things from 4 to 6, but not including 6. And there are 8, then there are 3, then there are 2, and there are 2. And for example, if I went through that and I had graphs going off the page, I could say which one is my tallest bar, and then for my window, I set that tallest bar as your maximum, so that it fills the whole screen. Okay? So, smallest number and largest number have to fit in your minimum and maximum. You want to think about what you're going to count by to make sure you have at least 5 boxes. You can go bigger than 5, but again, you want to make sure that you have a clear distribution of your heights. And then you're going to say, putting together your scale with your min and max, what should I count from, what should I count to? And then really the minimum, the maximum, the Y scale, all of those are just tweaking it to make it look prettier. But really, your calculator, if you can see this, you can get a general idea of what's going on, because I can hit trace and find out exactly what each of those heights are. Woohoo! Now my calculator is counting for me. Ding! Yay! Okay? When you do graph these, okay? Hello. When you graph these, you want to make sure that you always include what? All of your graphical displays should have what? Labels. So with this information, what would I label this as? What is it? Word length. This axis would be my word length, because now we're talking about quantitative data, not categorical. So this is word length. What would this axis be? Frequency. And usually you'll just have frequency for that. You're not going to do a quantitative data with percents on that axis. That just normally doesn't happen. It's kind of weird to try to do that. And then you want to title the whole graph. And the whole graph is basically you talking about your who's and your why's. Part of your why's are on your axes. But I would say, okay, Toni Morrison's Song of Solomon. And I would say, word length. Does that make sense? Okay. And then with my graph, depending upon how you chose to set up your bins, your descriptors might be a little bit different. And so whenever I ask you to describe, what are words, what things do you need to include for describe? Skew is a measurement of shape, center, and spread. Shape, center, spread are required. There's like a half thing that sometimes you'll have, and that's unusual features. So that's going to be things like gaps or outliers. But you're not always going to have those. If you have them, comment on them. But if I were to describe that graph, what would I say it is? Skewed right, because that is where my tail goes. Okay, you're always talking about which direction is it being pulled. So that's skewed right. How many modes? 1. So what do we call it? Unimodal, skewed right, and if my data is skewed, what do I use to describe center? Median. What do I use to describe spread? IQR, interquartile range. I don't want to do that. I don't want to calculate that by hand. Anybody want to calculate that by hand? Cool. Good. Let's be lazy together. Hit stat. I want it to do work for me. I want it to calculate. And I only have one variable. Plug that in. All my data is in list 1. I don't really have a frequency list. So I'm just going to calculate. Boom, shakalaka. Awesome, happy, happy, joy, joy. Because this has just given me a ton of stuff. X bar means what? Average, mean. This is the sum of all of your x's. This is the sum of all of your x's squared. Don't worry about those. Those are used in formulas that we're never really going to do by hand anyway. This guy here, the s, that is your standard deviation. If you have something in the s, use that for your standard deviation. If this is empty, then you use the lowercase sigma one. So if you have an s, use the s. If not, then you go to the sigma. They're slightly different calculations. Then, boom, 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 boom. Look what I got. Sample size, minimum. First quartile, medium. Median. Quartile 3, maximum. Hey, what's my inner quartile range? 4. And I am okay with you saying the inner quartile range is 4. I'm okay with you telling me the inner quartile range goes from 2.5 to 6.5. Both of those have their benefits. To me, I like knowing where the inner quartile range is. It tells me 50% of my data is between 2.5 and 6.5. Whereas if I wanted to find outliers, I need the actual value. I need that 4. So either one of those is okay with me. All right? Yes, ma'am. Unimodal, hang on. We know unimodal means one peak. This is going to be one of those things where it's the best way to explain it is by giving you examples of different ones. But what we have here, we clearly have just one high point. Some graphs, it will look like I have a high point, then it'll come down and it'll go back up again. What you really need to focus on is the difference in frequencies. If your difference in frequencies is only like 1 or 2, that's not a new mode. You want to look for kind of trends where there's a sudden dip and then a sudden increase again, where you clearly see it kind of coming up and then going back down. Mm-hmm. So let's actually show what you're talking about here. So when we count by 1, this is not going to be a second mode because there is only 1 bar between them. Unless it went here, all the way down, and then all the way back up. And even then, it's about what is your scale, how big is this? But usually 1 bar difference does not make a second peak or a second mode. But it's all about your justifications. This is all about you explaining what you have. Okay? Because there's going to be a lot of different answers that you could get for that. That's still definitely skewed. But you're going to see some examples where the textbook says one thing, and I say something exactly different from that. It's because it's how you graph. How do you justify? Which is why your answers in here are never just give me the value. Which is why, just like I told you on the quiz, I said if it asks for a percent, if you just give me the percent, you do not get credit. You have to show me how you got that, where that came from. Okay? So, we did that one. If I were to describe this one, describe always includes shape, center, and spread. If you have any bonuses, go for it. But what would you call this? Unimodal and skewed. And if you're ever going, I can't quite tell, pick one and justify. I would say this one is very clearly skewed to the right. Because my mode is here, there's only 1 bar to the left of it, and there are 1, 2, 3, 4, 5 bars to the right. That's skewed data. And that's kind of what you're looking at with this. So this is unimodal, skewed right, and if it's going to be skewed right, or skewed at all, what am I going to use for my center? Median. And so you could calculate the exact median by saying, hey, this one has 20 in it, this one has about 36, that's about 25, that's about 20, I don't know, 5, 2, 3, however you want to do that and figure out how many would be in the middle. But I would say it's skewed right, so I would look at my peak and I would make sure to move it to the right to try to figure out so that the total height of boxes, like the weight of my boxes, where would the weight be balanced? And so my balance, I think, would be between 2 and 3, but closer to 3, because I still have more over here. So I would say that the center would be between 2 and 3 hurricanes per year. Context. And I would say the spread, if I'm doing skewed data, what would I do? IQR, interquartile range. So I would say most of my hurricanes per year are going to be between 1 and 4. Or 1 and 3, I think, is a little bit too narrow. Okay? But you're going to have data. You're going to actually have those numbers. All right? Now, hopefully you guys watched the Boxplot video, because I'm not going to sit here and go over that again. So you need to be able to tell me, how do I find if something's an outlier? Wow. Anybody watch it? How do you find if something's an outlier, Henry? Not a gap. There was an actual formula. An exact number. And it had to deal with IQRs. It's with the fences. If it's more than 1.5 IQRs from quartile 1 and quartile 3. Okay, you are going to be quizzed on that, guys. It is just a fact. It's not something that has to be interpreted or anything like that. You just have to know it. But if you do not watch the videos that I tell you to watch, you will not know it. And I put that in a video because otherwise we'd have sat here for 15 minutes while you just write stuff down. Okay. Rachel. All right, so now what we're going to do, because that's the stuff we didn't quite get to last class, I want you guys, in your notes, this is the next page, to do problem number 1 for me, please. Do problem number 1. Every single time you do one of these graphs, you need to ask yourself, does my bin width make sense? And with that bin width, does where I start counting and where I finish counting make sense? Because very rarely, if you zoom stat for a histogram, is it going to give you really anything you can use. Okay, I'm going to show you what my graph on the calculator looked like, and then I'm going to show you what the textbook said the answer was. That was my calculator. Okay, let me show you what I did. First thing, if I zoom stat, this is what it gave me. And then I went to the window, and I said, okay, that minimum makes sense because I go from 10, I go up to 22. And so I'm going to do from 10 to, let's do 24. Because 22, if I put till 22, that 22 is not going to be in that box. And I'm going to count by 2s. Now, if I go to graph at this point, that's what it looks like. But my graph looked a little bit different than yours. Because when you graph something, when you sketch your graph, they're going to expect you to fill the graph from the bottom of the screen to the top of the screen. So what I did is I went to the window. I changed my Y minimum. I just usually do negative 0.1, so that just kind of scooched the bar up just a little bit. And I said, okay, let's see what that does. And then I said, okay, but I need to get the bars to go to the top. So I hit the trace button. I said, okay, my tallest tower is 5 tall. So in my window, I said I want it to go up to 5. And there's a graph that goes from the bottom of the screen to the top of the screen, starting and ending at reasonable numbers, counting by something that makes sense. What would I have labeled this as? Number of credit hours, or just credit hours. What would I have labeled this? You could have either said frequency, or you could have said students. Give it a little bit more detail. What would you have titled this as? Students, intro to stats, students, and you could have done credit hours or course load or however you wanted. You're giving as brief and as summarized a who and a what as you possibly can, with still getting in your context. So I would have said intro to stats class, or intro to stats students, credit hours. Now, let me show you what the textbook said. And I'll put mine and the textbook side by side. Those are a little bit different, aren't they? Okay, those are crazy different. Let me show you why. Don't do this. Please don't do this. They put 10 in the middle. They're still counting by twos. They still have 10, 12, 14, 16, 18, 20, 22. But I put those numbers in the middle, which means this first bar doesn't go from 10 to 12. It goes from 9 to 11. We don't count by twos and start at 9. That does not make sense. Okay? But what I want you to see here, changing something as small as where I start my graph off, look at how different they turned out to be. So it's very important that you have reasonably picked start and ends. So this graph, they should not have labeled it the way that they did. This is actually incorrect. They should have labeled it 9, 11, 13, 15, 17, 19, 21, 23. Okay? You never do it this way unless you are only dealing with integers and you have 1 for each box. Like if I said 6, and this is the 6 box. 7, this is the 7 box. This is the 8 box. That's the only time I ever want you to put a number in the middle. That's bad mama jamma. Don't do that. Okay? But depending upon how you choose things, it can really change the focus of your graphs. You want to be real careful. And really, the histogram is going to be the main graph that causes us issues. For pretty much all of the others, we just zoom stacked. But the histogram, its start, its end, its bins, those all have to be thought of first. You have to think before you can see what it looks like. Make sure that it makes sense. Now, for the mean and standard deviation, I'm lazy. I don't want to calculate that stuff, so I go to Stat, Calc, Enter. Boom, there it is. What's my mean? 16.312. What's my standard deviation? 3.701. Now, please understand that when you do mean and standard deviation, you need to have labels on them. Context. I don't know, maybe that's important to this class. I only say it like every single block, that's weird. And then just like I was able to pull mean and standard deviation from that, I can also go directly to my calculator and also pull up chickada. There we go. I can find my median is 16. I can tell that my interquartile range goes from 14.5 to 20. Or I can say how big is my interquartile range. 5.5, 5.5. Again, what do you need? Context. So my median is 16 credit hours. My interquartile range would be 5.5 crack hours. Okay? And if I were to describe this graph, and if I just kind of go off of theirs even, it's not like a pretty example of unimodal, symmetric, skewed, bimodal. It's not one of my pretty ones, is it? Hey, I know it's not symmetric, right? Because I can't fold that sucker. You can make the argument of what kind of skew you would have based off of what your graph looked like. So for my graph, I have no idea. That's kind of wonky to me. So I'm going to come and look at this information. My median is 16. My mean was 16.3. Are those pretty close to each other? They're pretty close. So because they're pretty close, you could make the argument that it's symmetric. You could say, well, based on this graph, it's skewed left. My calculator graph might have been a little bit different. I want you to take a breather, though. Okay? Don't freak out. I'm not going to ask you to describe a wonky-looking thing like this. When I ask you to drive, I've lost the ability to speak today. When I ask you to describe something, it will generally be falls a little bit closer to one of our nice topics. Okay? Which is why you don't see describe up here. All right, this one says it's more appropriate to use median and IQR because these data are not unimodal and symmetric. Basically, if you are unimodal and symmetric, go for it. Mean and standard deviation. We're going to hold chapter 5 is nothing but that stuff. But if it's not unimodal and symmetric, go with interquartile range and median. Okay. Yes, ma'am. We are going to round in this class, generally speaking, to 3 decimals. Well, actually, no, I said 2 decimals for percents, 4 decimals for probabilities. We don't have, beyond that, we don't have a set rule. And it's kind of funny if you look at the grading rubrics for free response, is they will literally give you a number that, goes out 9 decimals. And say, whatever they round to, make sure it makes sense. My general rule of thumb when we're talking about actual data is I say my original data was by integers, right? Do you understand what I'm talking about? Integers are my original data. So if I were to do my average, I would take it out 1 more decimal. So my average, I would round to the nearest tenth. And my standard deviation, I would take out 1 more decimal. Just get a little bit more specific. Okay? But there's no set in stone rule for that. Just don't tell me, hey, my interquartile range is 6. It's not. Okay? All right. So this chapter is about displaying and summarizing quantitative data, and we're kind of lopping this in with chapter 4, because chapter 4 adds 1 word to that. Compare. That's it. It says, hey, now if I look at 2 of them at once, what happens? You just use different language. But display and describe some quantitative data works a little differently than categorical. Categorical, the only really describe you could have is that idea. This guy, we have so much more. We have shape, we have center, we have spread. And this guy, if I change a value, or depending upon how my values are distributed, can make a big difference. So, when I have skewed data, this is hugely important. When we're describing unimodal and symmetric versus skewed data, I'm not pointing at your flipbook or anything. You have to make sure that you use median and interquartile range. And that is because medians and interquartile ranges are resistant to outliers. So, for example, Eli didn't take his quiz last class because he was absent. What I automatically do, for anyone that's absent, I put a 0 in for their grade. And the reason why, he's like, what? The reason why it actually makes really good sense. Have you ever had one of those classes where the teacher never put zeros in, and then it's like a week to the end of the marking period, and all of a sudden your grade drops like 20% because they've gone through and put zeros in? Yeah, we're not allowed to do that. Your grade can go up. So when you make up stuff, your grade goes up, but it won't go down. But that means that if you guys were to ask me what your class average was right this moment, that data would be skewed because I would have a 0 in it. I think in my other class, I had 2 or 3 people that were absent. That would make it even worse, right? If I told you the class average based off of that, y'all would be freaking out. Because skewed data, or average and range and standard deviation, are very sensitive to outliers. So when I have that 0 in there, it's not going to give you a good representation of how you did as a class. Now, when Eli makes up his quiz and we put a grade in there, and that's, you better not get a 0 because that would be horrible. Nobody got a 0 on this. That should definitely make the average more representative. Do you understand what I'm talking about here? Okay. So when we have skewed data, we use median and interquartile range because they are more resistant to outliers. If I were to talk about the average income for a year for this classroom, it would be skewed because I'm in here. I actually have a full-time job. Maybe some of you have full-time jobs also, but your full-time job is a student. So I'm not expecting it to be anywhere near mine. So average doesn't make sense. Median, now that makes sense. Also, sometimes we'll go through and we'll be like, it's so funny, your class data was due to be entered by yesterday. I haven't checked yet. But your class data, I have had people in the past, because this is why I no longer do centimeters. Because on the centimeters, they would do their height, and they would say, oh, look, I'm 34 centimeters. Because it says 34 up here. Not realizing that, you big dork, once you hit 100, it stops putting that first number down. So you're 134 centimeters, but you just told me you were 34 centimeters. So if I go back through and I change that, that's going to make a big difference to my average. But if I just change that and I'm using median and interquartile range, it's not going to make as big of a change. So adding or just moving the position to a group using median and interquartile range isn't going to significantly change you. Worst case scenario, you move over one. Your median's no longer smack dab here. Now there's one more person, so it scooched over a half. Now we're on the next person. That's all it's going to change. On the other hand, if we have unimodal and symmetric data, we do use mean. And if I'm going to be changing or adding values to that, it really can change. Because mean and standard deviation are sensitive to outliers. That's huge. They're little snowflakes. You don't want to be like too hard on them. They're going to melt. My precious little flowers, they're going to wilt. It's too hot. It's too cold. They're very, very sensitive. So that means if I were to change and I were to I made that mistake, for the most part, if I talked about height in here, height would be unimodal and symmetric, pretty much. But if some dork put in there they were 34 centimeters tall, and then I changed that to 134, boom, my average just did weird stuff. Okay? And you always want to kind of think about it in terms of how far is that change or that new data point going to be from your average. If I add a data point that is the same thing as my average, will it change my average? It's the exact same thing. The average quiz score in here was an 85. and somebody gets an 85 on the quiz. Will that change the average quiz score? No. But what happens is if I'm going through and I realize I typed one of those numbers wrong and somebody was supposed to have an 80 and I accidentally typed 8, it happens. It really does, which is why I want you guys keeping an eye on these things. And I change that 8 to an 80. Will it change my class average? Absolutely. Because the further away from the center you are when you put in a new piece of information, more of an effect it's going to have. But here's the weird thing. If I were to take everybody's age in here and I were to find the average of your ages, and let's say that the average age is 17, probably undergoing it a little bit, and another 17-year-old walked into this classroom, it's not going to change my average, but it actually does change your standard deviation. So you've got to be very careful with standard deviation, because standard deviation kind of talks about the height of your tallest part in response to the width, in proportion to the width. So if I've made my taller part taller, I've actually reduced my standard deviation. I've made it more predictable. It's more center heavy. Whereas if I push it out on the bigger your standard deviation is going to be. So is the weight more in the center now, or is it weight more on the ends? If it's on the center, you're going to be decreasing your standard deviation. If it's on the ends, you're going to be increasing your standard deviation. So you want to think about those things. All right. So this is the same set of data that we had before, but I don't want you to actually change anything in your calculator. I don't want you to do any of this with your calculator. And by the way, if you were to take this problem and then have put it into your calculator and said, oh, here's what the new value is, you would be wrong. This is asking me to say, suppose this guy right here was actually taking 28 credits. They don't want you to then go back and recalculate all of those. They want to know what changing that one value is going to do to your data. So if I change this to a 20, from a 22 to a 28, what is that going to do to my mean? Is it going to keep it about the same? Is it going to make it go up, or is it going to make it go down? The mean is going to increase, because the mean is sensitive to outliers. What's going to happen to the median? It's going to stay about the same, because I haven't, actually it should stay exactly the same. Because I haven't changed the number of entries. I'm not changing who's in the middle. I changed something far away. So the median should stay the same. The median should stay the same. What should the range do? Increase. Because the range is the maximum minus the minimum, and I've just made my maximum bigger. IQR. Stay the same, because that middle 50% is still the same, folks. Standard deviation? Increase. We're not going to be talking about shifting left or right. Standard deviation is saying, am I making my data more center heavy, in which case my standard deviation would decrease, or making it more side heavy? So I'm pushing it out further to the side, so that would mean it would increase. Now, I'm just going to show you how simple it is to turn the graph that we have into a box and whisker graph. You ready? Go to second y equals. Go into your plot. Go down and select the higher level box and whisker, the box and whisker with dots. You're going to zoom 9 for zoom stat. Done! That's it. And that's it. So if you need to see these written down, basically what you first did is you went to stat. You don't need to write this down. If you want to write this down, it's already posted. But I'm literally telling you, hit stat, enter, Then you're going to put your stuff into your list. Don't hit delete, hit clear. Turn on your stat plot. Use the Boxplot option. Make sure it says list 1. So I mean I have like spelled it out for you. But basically we said, okay, stat plot option, make sure that says list 1. Woohoo! Zoom stat. That's it. You don't have to worry about bin widths, minimums, maximums, starts, anything like that. You only do that with histograms. And your 5-number summary, you've already had this. This is just if you need to go back and write this down, you can come to this PowerPoint, which is posted on Canvas, and copy literally down the step-by-step instructions. I just don't think you need to write that down. You might want it later on, though. So what we're going to do is we're going to use these instructions. We're going to start with this data. You're going to create a histogram. Everything you need for the histogram. Find your 5-number summary. Range and interquartile range. Then you're going to do a box plot. The easiest aspect of all of that should be the box plot. Okay, go for it. Okay, so again, you would start this by doing zoom stat, and you'd see this. But depending upon how you edit to what you're doing, your graph can change from here to that, to even this. So what I want you to see with that is you have very different graphs that we're examining here. Do you understand how those are each very different? The only one that does not make any sense was the first one. And it threw me off because it said it went from 12 to 68.5. And I was like, 68.5? I was like, the biggest value I had was 59. What? Okay, so be careful with that. So this was using a count of 5. No matter what, your 5-number summary, when you do the 1-var stats, should give you the same mean and the same standard deviation and the same 5-number summary. What would your range have been? 47, because it's maximum minus minimum. What would your interquartile range have been? One more time. 19, or 23 to 42. No matter what, your box plot should be the same. This obviously doesn't have any labels on it, but I would have labeled this axis for both the histogram and the box plot as number of free throws. A box plot, box and whisker plot does not have a frequency axis going up there. They're always just the same width. But this one, I would have written players or frequency. I do want to show you something, though. What I'm going to do is I'm going to change this to my box and whisker plot. Gotta love that one because it's just a matter of zoom stat. But let's say I were to change one of my values. I'm going to change 59. I'm going to make that 79. Now look at what I have when I zoom stat. Do you see this guy right here? What is that? That is an outlier. That's actually might be an extreme outlier. Because it's about how many interquartiles away from this box are you. And what's nice here is if you're not sure which values are outliers, use your trace function. Hey, look, the outlier was my max at 79. Is that clear? Okay. So try this one.